So welcome to the video. Today we are looking at how to do a Wilcoxon signed ranked test on version 31 of SPSS. So we're normally going to use this test when we have an ordinal or continuous dependent variable, and when we have the within participants or within subjects categorical independent variable comprised of two levels. Basically that means when we have two time points. So for this example, we are imagining that we are interested in the self-efficacy of nurses as it relates to their ability to perform a certain procedure. So how confident do they feel in their ability to perform a certain procedure? And we're looking at whether that changes after receiving training on how to complete that procedure. So in column A, we have their self-efficacy scores before they receive the training, and in column B, we have their self-efficacy scores after they receive the training. So higher scores in both of these columns indicate higher levels of self-efficacy or higher levels of confidence in their ability to complete the procedure. So let's take a look at how to put these data into SPSS. So we'll go down to variable view by going to this tab down here, and in the name column I'm going to just put before here. So that's going to stand for before training, and then in the cell below I'm going to put after to stand for after training. Then we're going to go over to this measures column and we're going to indicate that we're working with ordinal data. Then we'll go down to data view and we can see that we have before and after now at the top of these two columns. So we can just go back to this spreadsheet and I'm going to select the top left piece of data, and then while holding shift I'll select the bottom right piece of data. Then I'll go to Command or Control C to copy the data, and then I'll go to the top left cell in SPSS and I'll go to Command or Control V to paste those data in. Sometimes that won't work for some reason, in which case you can just go to edit and down to paste, and that usually does the trick. And then once you have the data in, you're ready to run the analysis. So you can go up to analyze and then down to non-parametric tests, then over to legacy dialogues, and then down to two related samples. And we can see that we already have Wilcoxon selected here. So if we just select both of these levels of the independent variable and click on this arrow here, we can move them over here, and we can click on options and we can say that we want quartiles, which means that we're going to have medians in the output file. So then we can go to continue and then to OK, and that will run the analysis for us. And if we look at this descriptive statistics table, we can see that we have a median of 7 after training and a median of 5 before training. So it looks like the nurses were more confident in their ability to implement the procedure after training compared to before. But based on the medians, of course, we don't yet know whether that difference was statistically significant. And in order to determine that, we have to look at this test statistics table and at this asimp sig two-tailed row, where we have a sig value of less than 0.001. And as this is less than 0.05, we can conclude that there was a significant difference in self-efficacy ratings before and after training. So that's essentially how we run and interpret the Wilcoxon test. But let's also take a look at how we can write up these results. So we'll have an example here, and I've said that a Wilcoxon signed rank test revealed that self-efficacy scores were significantly higher after the training compared to before, and each time I've referred to a time point, I've included a median and an n value. So we have a median of 7 and an n value of 15 for after the training. So we'll just take a quick look at where that comes from. So we have this descriptive statistics table, and we have this median column, and we have the median value of 7 for after, and we have an n value of 15. We can see that we also have an n value of 15 for before, and this is just because we had 15 participants at the start of the study and we had 15 participants at the end of the study. So I've reported the median and the n value for after training, and then I've just done the same thing for before training. Next, I've reported this z value of negative 3.87, and that's just coming from this test statistics table and this z row here. So I've just reported this value here to 2 decimal places. I've also reported the p-value of less than 0.001, and that's just coming from the same table and from the row below. And finally, we have this R value. So the R value is an effect size statistic, and SPSS doesn't actually provide this to us, so we need to calculate it ourselves if we want to report it. And in order to do that, we just take the Z value and we can ignore whatever minus symbol might be in front of it, and then we divide that value by the total number of observations. So we had 15 observations after the training and we had 15 observations before the training. So we had 30 observations in total. So we can just take those numbers and put them into Google, and it's going to tell us that we have an R value of 0.71 rounded to 2 decimal places. And that's the value that we've reported here. And this value has been described as large based on these criteria that Cohen proposed in 1988. He said that an R value above 0.1 can be described as small, an R value above 0.3 can be described as moderate, and an R value above 0.5 can be described as large. Of course, 0.71 is bigger than 0.5, so we've described that effect size as large. So that's about it for the Wilcoxon signed ranked test on version 31 of SPSS. I hope that was helpful. If you have any questions, just let me know in a comment and I will try to get back to you. Thank you very much for watching, and I'll see you next time.